In this video, we're going to look at the most important internal data structures in the Jikes RVM. We're going to use Jikes RDB to look at those structures as they are in the boot image, which is the same way they will be once we run the Jikes RVM. But currently we do not actually run the Jikes RVM yet. We just looked at the boot image. So the first structure, which you also get when you click on the anchor toolbar button up here, is what's called the boot record of the Jikes RVM. The boot record is kind of like the root into all the data structures in the Jikes RVM, and it's also what is used at boot time to find things and to connect native and Java code. Let's first look at one of the fields in this boot record. So the boot record is a data structure, it has fields. In fact, this is a normal Java object. It's the only object of class boot record that has the same structure as any Java object in the Jikes RVM's memory, but it's kind of a special one because it's located at a well-known address. In fact, it starts at address 31 and 6 zeros, and the pointer pointing to it points a little bit into it, not at the first byte, because there is a header of this object. So those two fields up here are the header of the object. That's not of interest to us right now, and those fields here are the actual fields in the class boot record. So the first field we want to look at is called IP register. So this is a field of type address. Address is essentially a pointer, and this points to the first instruction that's supposed to be executed when we launch the Jikes RVM. So this points to a method, compiled method in x86 machine code, and it will be put in the program pointer or the EIP register of our CPU. So this here is the address, and you can double click on it, and Jikes RDB will show us the data that's located there, and in fact the data is code. This is the machine code at this address. This is the first instruction that's going to be executed. This comes from compiled Java code, namely from the method boot in class VM. So this is the compiled version, the native version of vm.boot that exists already in the boot image. And the type of this thing is a code array. That's essentially synonym to byte array, because it's just an array of bytes that was generated by the just-in-time compiler at boot image creation time. So we navigate back to our boot record. The second thing I'd like to look at is all those fields called sys something IP. You see that the value of those fields are null, and there's quite a few of them. Those are function pointers. So those are the addresses of native code inside the boot image runner. Namely, this is the thin layer of functionality around operating system calls and other native functions. For example, malloc or free. When you boot the Jikes RVM, the boot image runner will look up the pointers of those functions, of those C functions, and will put them in those fields of the boot record. And afterwards it will jump to the IP register address, and from then on the Java code can look up in those fields where the native functions are that are executed. And the last field we want to have a look at here is the talk register. In the Jikes RVM there's a data structure which is central to everything. It's called the Java Table of Contents, JTOC. And there is a field here in the boot record containing the address of that structure, and we can follow that address and look at the structure. So this is the JTOC. This is a structure that's not actually in the form of a Java object. So it sits somewhere in memory, but it's a very special layout in a way. The address we just jumped to is in the middle of this structure, the center. the addresses with positive offsets here, locations or slots with positive offsets, they contain pointers, references, and the entries in this table with negative offsets, they contain primitive values. So let's first look at some references. The center here, offset 0, actually contains nothing, null. But if you go to offset 4, it contains something that's called literal. If you know Java bytecode, when you compile a Java source file and you use some kind of literals, let's say a string literal or double value or a long number that will be used as an immediate operand somewhere in your code, this literal value has to be put somewhere, and in Java bytecode that's put in the constant pool of the class file. When the class file is loaded into the virtual machine or during boot image writing, these constant pool entries are stuffed into this JTOC. So this thing here is essentially a literal of type string. So it's a string literal that comes from a Java file, and we see here the contents of this thing. So it's a string L, or EM magic, and so on. That's one kind of entry in this JTOC, all the literals. JTOC is pretty big. A second type, if you scroll down a little bit, you'll find different kinds of entries. For example, a tib. So tib is a type information block. It's an internal structure in the Jikes RVM representing a type. This slot here points to a tib object. So it's a pointer, like all the entries here are pointers or addresses of a tib object. And this specific thing here points to a tib object representing the Java type void. And you see the next one representing Boolean, and then for any Java type there will be such a tib object. And all of those tib objects, pointers to them are stuffed into the JTOC. So you can scan the JTOC, you'll find all the tibs that are there. And the tibs are some kind of special object on the heap. You can follow this pointer here by double-clicking. And now we're inspecting this tib. Kind of looks like an object, has different things in there. We'll look at that more later. Let's go back to our JTOC. So we have tibs, then we have other things. Scroll down a little bit. Here, for example, a field. So static fields in Java classes, not instance fields, but static fields, they're kind of global variables, and then it will be stored somewhere. They're not stored inside an object, but they are stored in the JTOC. This here is a JTOC slot containing the static field arc helper of class configuration. The type of this field is IA32 machine specific something. Okay. The value of this field at the moment is a pointer and address to some object. So static fields, all of them are stored in here. When you do get static or put static, essentially you're updating this memory location here, put a different pointer in here. Then you also have things that are combined field and literal. So if you have a field, a static field in a class that is initialized to a literal value, let's say you have RVM version string equals Jikes RVM 313 in your source code, this will be compiled into some constant pool entry by the Java compiler, and this constant pool entry will be put into the JTOC, and it will serve as a way to find this literal, but also it serves actually as the field. So this is field RVM version string of class configuration, and the type is a string, so it points to a string object on the heap. So we've seen field, field and literal, or literal, and we've seen those strange tibs. There are other kinds of slots in the JTOC holding other pointers to stuff. For example, there's the method. So let's look at one example. For example, this one. This is method process of class options. The type of those method fields is code array, because compiled machine code is stored in objects of type code array, which is a synonym to byte array, really. So if we follow this pointer here, we double click on it, we will see the code of this method process, the compiled native code of this method. So by scanning the JTOC, you can find all the native code for all the methods that have been cheated so far. We have another kind of entry, which is a constructor. This is just a method. So for example, here we have, let's look at this one. This is more interesting, or maybe more special. It's the constructor of Java long object. So init, name constructor of class Java long object. So here will be the code that's executed whenever you create an object. And besides that, we also have the last kind of entry, the very bottom of this table, and you see the table is really, really long. Here, this is a slot that contains a pointer to a Java long class object. So any class that's loaded into the Jikes RVM, the pointer to that class object will also be stored in the JTOC. This means that you have, for any class that's loaded into Jikes RVM, a tib somewhere on the heap, and the pointer to that tib in the JTOC, and the class object, Java long class object, somewhere on the heap, and the pointer to that in the JTOC. So that's the Java table of contents. Now we've already seen that there is a primitives tab here. So in the JTOC, the negative offset contain primitive values. You see here category literal. So if you somewhere need in your source code use some constant value, a literal integer or long, or a literal double, then those are also put in the constant pool, and these entries are also put in the JTOC when the class is loaded. You see different things here, and the more interesting ones are probably, let me see whether I can find it, somewhere quite, oops, this jumps a lot, quite further down. Here we have some that actually are split. So this is a field called I2D constant in class math constants of type double, and a double field really is 64 bits. The slots in the JTOC are 32 bits, both the primitive slots and the reference slots, because it's a 32-bit virtual machine, so pointers are 32-bit, meaning reference slots will be 32 bits. Primitive slots also are always 32 bits, and if you want to store a 64-bit value, it will consume 2 slots, and they'll label as field high and field low. So this is a double value split into 2 32-bit quantities. Now, we have already seen a few different kind of objects. So maybe the most interesting thing is a normal object. So we saw at the very top a lot of strings. So this here is a literal string, and you can look at the string object. So this is in RDB the way a string object is shown, or any kind of object is shown. Up here you see the address at which the object is located. You see that it's an object, a normal Java object. You see what the type of this object is. It's a Java long string. For some objects, for example for strings, you also see this light yellow box here, which gives you a summary of what this object is. So for a string, we just put the contents of the string here. So this is a string object representing the text, L, or, and so on. Below the yellow box, you have the header of the object. So the header consists, as I said before, of 2 slots, 2 32-bit values. One, the first, is a pointer to the tib describing the type of this object, and the second one is a status word. Below it you have 4 instance variables. So the top one here is the value. It's a pointer to an array of characters. It's defined by the Java long string class, right? The count tells you how long the string is, and the offset tells you where in the character array the string actually starts, the offset of the first character that is considered part of the string. If you look at this here, you have a blue cell here. Whenever there's a value cell with a blue value, this means it's an address that points somewhere into the heap and you can follow it. So I can double click here and I will see another thing, another data structure, namely an array. So at this address here, you have an array. The type of the array is character array. And for character arrays, we also show the contents in a compact form here, so you don't have to read vertically. Character arrays, as every other array, have 3 fields in the header. Like objects, they have a type. You need to know what the type of this thing is, a status word, but they also have a length field, 32-bit length field, which gives you how many characters you have in this array or how many elements you have. And then down here we have each of the elements. Each element takes 2 bytes because it's 16-bit cars. So that was objects and arrays. Now I said that we have these tips, and we can look at the tip. So every header of any object or array has a tip pointer, and if you follow that, double-clicking on the blue thing, you see the tip. So now it visualizes, RDB visualizes a tip. The tip is located also in the heap at this address, and it's a tip for what? Tips are special, they describe a type, and so we also say what type they describe, a character array. So this is the tip describing a character array. A tip is kind of like an object or an array. It's somehow a hybrid. It's like an object and like an array. It's more like an array, actually. So it has 3 header fields. The first one is a tip. So a tip also has a type. It's funny. So tip points to a tip for the tip. Status, a length, and then all the slots. Kind of like an array. But arrays are homogeneous, so every slot has the same type. Tib and other kind of runtime structures have potentially heterogeneous kinds of slots. So there are 19 slots in this specific tib. The first slot at offset 0 for any tib is a pointer to the type. We'll look at that later. So this gives the type object that's behind this pointer is going to give us much more information about what that is, what a character array really is. And then we have some things that have to do with inheritance. If we have a tip for an array, then we should have the tip of the element, which we don't have here. Not sure why not. And then a more interesting thing here are all these virtual method entries. So this is the virtual method table. So for any virtual method supported by this class or this type, and an array in Java also has methods it supports, for example, equals and clone. We have a pointer to the corresponding machine code. So those are the entries of the virtual method table pointing directly to code. For example, we could go here, double click, and this now is a piece of code. It's kind of like an array of bytes. You could look at it like an array of bytes, just machine code. Or you can look at it as a disassembled x86 sequence of code. You see it starts with the push instruction and ends with a ret. You also see up here that this is the byte array, or this is the code array for the method object.clone. And then here you see the mnemonics of the instructions, you see the actual machine code for the instructions, and you see the gray highlighting, which tells you which bytecode instruction each machine instruction belongs to. So this method here corresponds really of 3 Java bytecode instructions at index 0, 1, and 4 in the bytecode. So if you switch to the bytecode tab, we see the Java bytecode version of this method, which is 3 bytecode instructions at offset 0, 1, and 4. And we also see where in the source code of the Java lang object class this method is located. Okay, so that was code array. So tibs, arrays, objects, and code are probably the most prevalent kind of object. The other one is what I've already discussed, the JTOG, which is really different in terms of it has no header and has a fixed location, it grows up and down, so that's a very special structure. Also it has a fixed size, which is predetermined at the build time. You can fill it up, but it takes a long time.